This is one of the 7-way testers that I built. Helps you test and diagnose the 7-way cord on a trailer, the marker lights and the lights and brakes, etc. I decided to make this series of videos because I got a couple of requests to do so. And a couple of reasons why I started building this was one, we had one years ago, but it didn't really do much besides the fuse feature in it. So it helped you detect shorts. The other reason was I'd have PDI techs that would use a jumper wire to test the 7-ways, if they even tested them. And when they did so, if there was a short in the trailer, it would just start melting the wires together. We wouldn't find this out until the customer came to pick up their trailer and the lights wouldn't work. They'd come get me and I would find there was a blown fuse in the vehicle, and then you find out there's a short in the trailer. They wouldn't be able to take the trailer. So I started building these, testing and improving on them. There's a few features in here that you may not be interested in. I put them in for a reason. One of those was one brand started mixing LED and incandescent lights in the marker light circuit, and it would do weird things to the lights on the box. So I came up with a solution for that. Another brand started using the side marker lights as turn signals also, so it would do both functions, and I wanted a reliable way to test that. This isn't really a DIY or weekender type of project. It's more for the professional that's going to be using the box to test PDIs on a daily basis. So when I was trying to lay out how the box would look on the front and be usable, I don't have a lot of CAD experience, so I would use a piece of graph paper. And this was actual size of the front of this particular box I was building. So I would just try to figure out my spacing that way. Now the box I'm using in this video I got from Radio Shack, and I don't think you can get them anymore. I bought a case of them, so I was able to build a few boxes with that style of box. I'm going to put links to other videos, and I'll do a parts video at the end. But it also came with metal lids, so I made a template at one point when I was building a few of these, and that's what you're seeing here is the metal box. But when I didn't have the template, I would just use the graph paper laid on top to try to get my pilot holes started. So I start with a pretty small bit and then just work my way up. You can see the disaster there. I was trying to do 2 or 3 lids at the same time, but they're pretty fragile and I didn't have anything in between them, so they flexed and I broke some. So I'm only going to be working on this one box. And then I use a scroll saw to cut out the square holes. I've tried a lot of different ways, and this scroll saw has been the easiest for me. I just learned over time, just cut on the outside of the line, and then I don't have to do as much filing and modifying to get the different components to fit. Those are the holes for the meters. So I'm just doing a dry fit there. And then these are the holes for the fuse holders. And do another dry fit there and make sure I've got my cutouts correct before I do the rest. And then that's for the main switch. and I like to step my round holes up. So you'll see I do a few different steps here before I reach the final size. That's for the LED fuse indicators. That row there is for the LED lights and for a couple of switches. And the bottom row there you can see is for the main switches. I'll show later on, I robbed these parts out of another box that I had built before, and I'll show you why. I used them. Some of those switches were hard to reinstall. So here I'm just trying to find a good center point to put the handle in. In the past, I'd always forget to put the handle in, and I'd have to do it after the box was built. It would be a pain, so I remembered this time. And now for the actual 7-way socket, I just try to get it centered. Another thing, I always get some of the stuff too close to the edge. I've been lucky so far that everything's been fitting and working. But you have to be careful, like with the switches, and that you don't get them too close to the edge, because then the lid won't close. This hole here is for, see I put a little cap there. That's so you can reset the amp meter. DC amp meters typically need 0 points, so if you need to use that feature, I just put an access hole so you could do that. I just pre-drilled and put the mounting screws in just so that part's done. We will have to take that in and out. Now we're going to start putting the components in. You just want to make sure you get the amp meter in the position where the hole is, so you can access the reset button. Like I said earlier, I had an issue with some of these switches, putting them in, but it worked out. Some of the tabs broke off, so you'll see here in a minute. I like to glue them in, because those round switches can spin. So I put a little glue on them so they don't spin. And here I'm putting in the LED lights. So I tried to find the colors that match with the wiring on the 7-way. Back in the olden days, when you pull the 7-way apart, it would give you a color of where to put them. Now I think they tell you what function it does. So it's hard to find a yellow, so I use an amber for the brown. That was the closest I could get to brown with the brand that I bought. And then the clear one is actually for your auxiliary or your backup lights, and I just use clear for that one. Then you can see here I'm just hot gluing them into place, trying to make sure that the switches are square. I think I've got about a dozen hot glue guns, and this one's my favorite. I'll show you the model number here pretty soon, but it actually heats up really fast. It's small and compact, so it's easy to access these areas. So it's a P306 from Ryobi. So this was the box I built. This was another brand. I'll make a video just talking about those, but I had it in the back of my Corvette with the bubble window and it melted it. So I decided to rob the parts out of that to build this box. So this is definitely not a soldering tutorial, but I did solder this component here. This is an auxiliary power. So this particular box doesn't have a battery inside of it. Some of my other ones do. So if you get a unit that doesn't have power, you can use this to supply power to the box. So if there's no battery in the unit, the trailer, and you want to test the lights, you still can. You can easily add auxiliary power to it. Another example is you can test towed vehicles. So if you put a tow bar in front of a vehicle, you can test your wiring with this, but you would need auxiliary power to do so. So another thing I always forget is I like to put magnets on the back of mine. Totally optional, but you can stick it to the frame when you plug the 7-way in. So a friend of mine mentioned that, and we started doing it, and it's worked out. But it's definitely not necessary. So these magnets are pretty strong, so you got to be careful. There's going to be some other videos that are kind of in between these, and I'll leave links to them in all of the other videos. So here I'm trimming off the screws so they're flush in the box and they don't have the point inside the box next to the wires. Not that there's anything that's going to happen inside of this box. I've had some I've been using for years. They've been dropped, and I always give them to the new employees. I've been doing that for years so that they're kind of testing them for me, with inexperienced guys using them, and they've held up really well. So this is the one that I left in the back of my '89 Corvette one day in the summer, and got melted, so I decided to use the parts out of that. That's why I was having a little bit of struggle with some of the switches in the previous video. They were used. Not that this one had been used very much. It hadn't. And I also used some of the wire harnesses out of it. So when I start to wire them, I usually use or do the negative circuit first. So I make my own diagrams just on graph paper. That's how I've been doing it now. Eventually I'll get them on a computer when I find a program I like and I learn how to do that. So we're just going to do the negative circuit for the switches so that light will work on the switches. You can see I've already got this made up, but I'll show you how I make that. I just take flag terminals and drill a hole in them so the wire can pass all the way through. So I'm using the blue ones, that way the insulator will fit through there easily. You can see there now the wire will pass through there. I've used solid and stranded. It's probably easier with solid wire. I'm demoing here with a stranded wire. So I just use a red one at the end, the first or last one, however you want to look at it. So that just gets a red flag. And then I would line them up with the switches to get my distance. And then just go all the way across. So you can see there I strip back enough wire so I make sure it gets a good contact. So I'm just trying to get it lined up, get them crimped. And I'll just show the process one more time. So you can feed the wire in, figure out your distance. I put a mark on it where I want to strip the wire back. And then just work that insulator all the way off there. You know, expose enough of it so you can crimp it. And that's how I made the jumpers. I used the flags to try to save a little space in the box. I just got used to doing it with one version of the box I made, so I keep doing it. And then you just install them across the negative part of the switch. So we're going to do the same thing across the power for the input power for those switches. So the diagram here is showing, you can see the 4 switches there in the middle with the jumpers. We're only going to power those 4 switches. The other 2 switches get powered differently. So once again, I already had that one made up, so we're just going to go across those first 4. And those receive power off what I call the main switch. So I put it on the bottom terminal, so we can go position 1. That supplies power to that bottom terminal and then across to the switches. Here I'm just installing the LED lights. So I went back and made sure I turned them because they have little slots in them so that the negative wire would be on one side. So they're all uniform. So there's different relays I use to cut off power to different circuits. So they only work in certain positions. That relay board there, I'll post a video on how I made that board, and that is to turn off power to those LED lights. And I'm just trying to clean it up a little bit. This will actually change a little bit how I have those connected. And that's the negative side of the LED lights for the fuse indicators. And then the meters need power also. I really like using the Wagos for this. Wire nuts and other things, they were a pain. Wagos work way better when I need to parallel these circuits. So I did combine a lot of those circuits together. The load is very small, so I'm not too worried about the load. And like I said, I've got a bunch made up like this that I've been using for, years. So those other 2 relays I mounted earlier, they need negative circuits also, so that's what's hooking up there. So I wasn't able to reuse all the wiring out of the other box, so some of it's going to be new wiring. That's a 12 gauge jumper wire that we will discuss more later. So a little review of what we just did. These are the switches. This is the top half of the box, bottom half of the box. So these just get paralleled all the way across because all the switches have lights in them. So that's our negative circuit, goes to that Wago there. And then the switch positives were next. So these are just the first 4 switches. So your right turn, left turn, your marker lights, and the brake. Those are going to only get powered when we're in position 1 on this, what I call the main switch. Okay, then we have, these are the LED lights here. They correspond to each one of these circuits. Those get tied to the Wago. These are the fuse indicators. So if the fuse blows, one of these will go out so you know which fuse blew. They're hard to see otherwise. So those go to that Wago also. And then the meters, they're going to go into that Wago. And these 2 relays, this one we'll talk about more later. That goes to there. This is the one that turns on and off these LEDs, and that needs negative power there also. So this is for the relays that are in here that aren't represented. And then we have the jumper, which was this circuit here. See, it's going to jumper down to the bottom of the box. So I'm just going to confirm here, which is my common post, my normally open and normally closed post for this relay. This relay here controls the LED lights. So in the 0 position of the main switch, those lights will work. But anytime we push position 1 or position 2, then those lights will be taken out of the circuit. And so here I'm just connecting them. We want them on the closed portion of this circuit. So it doesn't matter if it goes on the common or the closed. It will matter later when we connect the second wire though. We have to make sure we match up the brake wire, the running light wire, the left and right turns. Those will matter. So I take those really small wires from the LEDs and I fold them in half, make them a little bit thicker so the terminal has more to grab onto. And I'm just cleaning it up a little bit. It's still going to be a rat's nest at the end, but I try to clean up as many circuits as I can. So in review, what we did here, these are the positive side of the LEDs. Your marker, left turn, right turn, and your backup. So ignore that. There, that's a mistake. That's actually the positive side, triggering those relays that are on there. This is representing the negative side. And then you have your common, normally closed and normally open. So right now, this would actually be going all the way through to the light. So if we had this plugged into the vehicle, turn on the left turn, it would go from here through the closed switch to the light. So we could see that light flashing. Goes the same with all the rest. So you can see I have them tied in at the 7-way. So this would be going out to the different flashers or relays, and then these are tied into the LEDs. Now we're going to do a little bit of the positive circuit, upper right hand of the diagram. We're going to supply power to the meters, and then these little jumpers are going to go from the Wago to the fuses. So I just did it this way. To me it seemed easier than trying to jump between each fuse. Just go from the Wago to the one side of the fuse. So in review, we're tying in this portion here, this top right of the diagram, where we have our fuses. We have the input side of the fuses, the output side of the fuses. Those just tied into the Wago. It's our positive Wago right here. And then the amp meters tied into that Wago also. And later on we'll be putting in another jumper that goes from the top part of the box to the bottom part of the box. And this is where you're going to get your power from. So either from your auxiliary power or from the 7-way. So the 7-way goes through here, up into here. It's going to work on the auxiliary circuit or the backup light circuit. It's getting its own power. So if I tied that in with left, right, turn, and the marker light, I was having an issue with that circuit overloading with the size fuse I wanted to use, so I could keep it sensitive enough to detect shorts. So it gets its own circuit, because not all trailers have a backup light either. So you can see it's going to go from its own fuse to the center part of the switch, which is going to be our input. Maneuver it through there a little bit and connect it to that switch. That's our input. Then the output that's going to go to the 7-way socket itself. You'll see these all have jumpers on them. So the other one is the LED light. So if I wanted to test the 7-way on a vehicle and see if that backup light comes on, that's what this is doing right here. So a review of the auxiliary or backup circuit. You get your fuse power here. So previously we saw we had power coming from this way over to here, goes through the fuse. This gets tied in with the LED. So if this fuse were to open, this LED would go out. This circuit would not work. But then that goes to the center part of this switch here. So when we turn on that switch, it's going to feed power to the center post here. So that circuit is all on its own. It doesn't always get used. So that's also tied from here going up to the LED light control board here. So here we're going to start with the flashers and the relays in the bottom portion of the box. we're going to put the negative circuit across there. They just parallel across. So you can see these diagrams weren't made for this video. They were made for me just to remind me how to wire each circuit. So sometimes they don't make complete sense. I'll try to explain them the best I can. So here you can just see the flashers do have a negative and a positive post, this brand that I'm using. But the relays don't. The coils aren't polarized. So I still try to put them some kind of universal thing. So if I put it on the right, then I try to stick with the right. Then we're going to work on the power here to the main switch. So that top fuse is going to feed the marker light circuit. So you can see here it parallels off of that center post. Goes down to that relay, and that's the input feed for the marker lights. So that's just coming off the fuse, and I'm measuring the wire to length to go to the center post on one side of the switch. Then that green wire is going to feed the relay for the marker light. So they're just paralleled on there with a flag connector. So that's actually input power. So when that relay closes, that'll put power out to the ring light circuit or the marker light circuit, and then the other side goes out to the 7-way. Then attached on the 7-way end of the wires, we have the small wires that go up to the LED relay board. So you got to make sure that these go to the correct position on these. Then we're going to work on the rest of the marker light circuit. Here I'm crimping a diode into a flag that's going to go on the switch just to prevent any accidental feedback through that circuit. So you can see the LEDs on the switch side. And then that wire is going to go down to the coil of the marker light relay. So that's the positive side. So when we engage that switch, it'll close that relay, turning on the marker lights. So what we've done here, this top fuse here is going to center post on one side of the main switch. So this center post of the main switch is also going to have paralleled onto it power to the relay that controls the marker lights. Okay, so when this gets powered here, it's going to close this relay and supply power to the marker lights here. Then the small green wire is going up to the relay board that controls the LED lights. Okay, so that's this other small wire that we had put in there. And then I'd added a diode here, so off the marker light switch, that goes up to here, which parallels over to here to turn on the marker lights. So this switch turns on the marker lights, and this switch turns on the marker lights. Just not at the same time, different functions. So here I'm just using some Velcro to mount the flashers. They've been working pretty good to hold them in place. If I need to replace one, I can pull them out individually. Now we're going to be working on the brake circuit. We're going to do the switch to the relay coil. So when you energize that switch, it's going to energize the relay coil. And that's for testing the amp draw on the trailer brakes. So a lot of things are going to parallel in this brake circuit. But depending on where the main switch is, on whether what's involved into that circuit. So whether the LED light's going to function or the brake magnet is going to be in the circuit. So right here we're tying it on to the other side of the coil. So one post is going to come off the main switch, the other post is going to go to the junction. So there's the main switch. So a lot of these wires are a lot shorter than they look like on the diagram. They just have to go up to this Wago. This wire's pretty long because that's actually the power to feed the brake circuit when we're trying to get an amp draw off the brakes. So I just want to make sure that that's going to close because I do tend to put that switch pretty close to the edge. Okay, and this is for the brake magnet. So I want to be able to take that brake magnet out of the circuit. So depending on the main switch position, if it's in 0, that brake magnet is in the circuit. If I move it to the other positions, it energizes the relay and takes it out of the circuit. So once again, that can be paralleled right into the Wago there. Now we're just hooking up some of the negative circuits in the bottom of the box. Negative side of that magnet and some of the other negative circuits that are in the bottom of the box. The one that controls the jumpers across the relays and the flashers. And the auxiliary power one, we can just tie those in now. The negative circuit's just one giant paralleled circuit. So now the LED light for this, if we're testing a brake controller, does not have to go through the relay. That circuit is not affected like the other ones were. So it's actually direct down to the Wago, the junction where all of the brake circuits connect to. Then from the actual 7-way socket, we just run a wire to that junction. And I don't have a jumper at the 7-way for the light because it's at this Wago here. Okay, so we went from the brake switch to the relay. So this is going to trigger the coil on the relay. This switch would have to be in the right position to supply power to this before that could happen. Then this is our output. So when this is energized, this will go to this Wago here. So there's a whole bunch of stuff paralleled right here through a Wago. And it's because of, depending on how these switches are operated, what's actually going to make it to here. So the main switch, it gets its power from its own fuse. This is a brake fuse. Goes to the center here. And then it's going to come out and it's going to feed the common on this brake relay. Okay, so turn that on. This switch has to be in the right position to supply power here. Turns that on. Then this closes and then it'll supply power to here. And then we can measure the amp draw on the brakes. So then the brake magnet, I've tried a lot of different resistors to be able to read a brake controller. And someone mentioned in one of my videos they used a brake magnet. I was like, well, I'll try it. And I just clean up some used ones and put in here. And they've been working fine. So off the brake magnet, we come over here to this brake magnet relay. And this is the common here. And this is closed when it's not energized. So when this switch is in the 0 position, this is closed to here, goes through the Wago and to here. So we'd actually be reading it back this way to be able to check a brake controller. Okay. So we did that. We got this here to there. And we tied in some of the negative circuits. So there's a bottom Wago that has negative circuits. That's what we did next. We tied a couple of those negative circuits in the bottom box to there. Then we did the LED light. So from here, once again, that just goes right to this paralleled Wago here, where everything's going. This can just go on top. And then the last thing we tied from the 7-way to this Wago, where everything's paralleled right there. Now we're going to address the left-right turn signals. This may seem like a complicated circuit. It's not really. But you can see we have some on-off switches, then we have jumpers to this other switches, then we have another jumper that goes down to one of the flashers, then the 2 go to the other flashers, and then out to the 7-way. So we're going to start here with the 2 smaller wires that go to the LED light. So they're going to go to this relay board. So once again, you got to make sure it goes to the right terminal so that we are going to the left turn on this one. Same thing with the right turn circuit, the brown wire. Okay, and then we feed those into the 7-way socket. Then you'll notice there's a white dot on one of the flashers. That's the slow flasher. That's how I know it's the left turn signal. Okay, so that's going to tie onto a flasher. Then we're going to mount these 2 switches. Those 2 switches are primarily for the dual flasher, which we see we're hooking up the output to that right there, and there's not resistors, there's diodes on that, so I don't get a back feed. And then those are going on to the test switches. So the video that shows you how to operate all this will explain how all these circuits work. All right, we'll see if we can make a little sense of the left-right circuit. I do a lot of things with it, so we started off by hooking from the 7-way socket to our relay board. So I can turn off the LED lights. Then working our way from the 7-way, you can see these both go to these flashers. One of these flashers is faster than the other. So I used to have to make my own, and now I've found some adjustable ones. So they actually make some that are adjustable. So I adjust it all the way down and I cut that off so it'll fit in the box. So when I'm in a test mode, you can see the actual video of how this thing works, and then you'll see how these circuits work. But this just parallels on, goes through this switch. This is a switch I use to try to test for shorts. Then it goes through this other switch, which when this relay is operated, I can turn off the left or right. So if I just want to see one side of the coach, this was put in so I could test those coaches that have the running lights on the side also be turn signals. So that's why that circuit's in here. This is only energized when this is in the 0 position, and it's going to get its power from here. And we're going to do that here in a minute. So this, we'll explain this later. Right now we're just concerned with how this just parallels all the way through over to this. And these have diodes. So when we do turn this switch on and this is flashing, it's going to go out. So it's paralleled here, so it doesn't matter if this switch is on or off. It's going to parallel down to these two flashers. Doesn't matter what's happening here because this is just going to go out to the 7-way. So when this one's flashing, right, so it's flashing, sending a signal out here. And when these are on, it can't backfeed. And that's why I put diodes here. Okay, can't backfeed. So this would go parallel through that as long as this one's closed. And parallel through that, just jumps through everything and goes to there. So I hope that makes sense. If you have questions, let me know in the comments. I made another diagram that's a little bit more accurate to how this box is wired up. So what we've done here is we're putting in this wire here from the center of the main switch, and it goes over to a Wago. And then we hooked up that other one that goes from the fuse to this Wago. So I'm going to try to break this down step by step. So this is what that relay looks like all soldered up. The two diodes on one side of the coil, your negative wire on the other side of the coil, and then I'll show you how this relay works. So whenever I make a video, people always say, why didn't you put the numbers? Well, there are no numbers on this. And I've never used the numbers. I've always metered out the relays and figure them out. So the first thing I look for, which is usually pretty easy to figure out, where's the coil? All right, this is the part that gets energized and moves the switch inside the relay. So I can find that here by just finding the one with some resistance across it. Okay, there we go. There's some resistance across that, so I know that's it. And then you kind of look for the oddball one, and sometimes this is the common, not always. I've got some of those other relays I use the commons in a different spot, but that's not, we're only worried about this one right now. So you can see that, that's shorted to there. And that's what we're interested in. So when we get power across here, it's going to open up. See, the other one is not connected right now. In this case, we don't care. We care about that. Okay. So that's how this relay is wired. Well, it's hard to see, they're small. I don't like really using this. I don't like putting solder inside the box. I think the solder joints are the ones that are going to fail first, you know, if you drop that box too much. So far it's been okay. Okay, so next, power to the switch coming off this side of the relay. So whenever this is not energized, this power will pass through to this switch. And this switch, I want this to have power in 0 position. Anytime we have position 1 or 2, it's going to trigger this relay, opening that circuit. Then we wired in the negative part of that relay. And then we actually applied the power here. So that's where it's coming off the fuse and feeding the center part of the main switch. Okay, so we did output, we did negative input, and then we did positive input. We'll go over this a couple times here. So this is the positive wire going to the LED light board. That's a Wago that's going to tie in a bunch of these circuits together. So one of the diodes goes to the Wago and the other diode goes to the switch. That's the negative part of the bottom row switches, so the light will operate. And we're going to tie that in with the LED light board negative. So they just get paralleled together. And then this is a trigger off of the main switch going to that Wago. Okay, then we connect the positive wire for this relay board, which is going to go to this Wago. And then the diodes that are soldered right onto the coil of this relay, one's going to go to that Wago and the other one goes directly to this switch. So this board's only going to open up when the switch is in this position here. So this goes to here and then goes out to here. But it'll also feed this and open this circuit. So anytime this switch is energized, this circuit gets opened. And then we went from this post here to this Wago. Here I'm making up a little harness for the brake magnet relay. It's got a couple of diodes in it because it's going to get fed from both sides of the switch, the main switch. So I have a long lead and a short lead. So we're going to connect that little harness to one side of the coil on the brake magnet relay. And the long wire is going to go up to the top there, the Wago at the top. So when the main switch is put in one position, that's going to send power to that coil and open up that brake magnet, taking it out of the circuit. and that's the positive to the coil on the LED light relay board. And now we're actually connecting the magnet relay. And then I've got those parallel together, a diode with the red wire, which is going to feed the bottom portion of the box. So when the main switch is in the other position, it's going to open up the brake magnet relay. It's also going to trigger the fast and slow flashers. So there we just hooked up the short end of that harness we made earlier. That's the power input from the main switch. And that's the jumpers going to the fast and slow flashers. Okay, then we took this blue wire that's going to the magnet relay. That's going to go up here to this Wago here. Okay, that gets triggered off of this side. So we're in that position, goes through here, and triggers this relay, opening up the brake magnet circuit. Then we actually tie in this relay board wire to the Wago. And then we're going to hook up this right here. So this diode's tied onto this red wire, which is going to feed the Wago that's down here to control this one. It also controls, because in position 2 we want to energize these flashers. So that's what those two circuits are doing there. Okay, this video we're gonna finish things up. So we look through there to see if there's anything I forgot, and the last thing we have is the output to the dual flasher. So that switch controls the trigger for that flasher that'll flash the left and right at the same time. Okay, so the switch that controls that dual flasher, because it's going to flash the left and the right at the same time. We're just hooking it to there and then down to the triggers there. These are labeled on those flashers, the plus and minus. Next, we're going to connect the Hall effect for the amp meter. So I'm trying to show the arrow there. We'll do it in another video. I'll make it more clear so you can see that there's a directional arrow. So if you put a wire in backwards and you're getting minus, just run the wire through the other direction. It's about that simple. So in this particular box, I just have power coming from the 7-way and then power from the auxiliary input. And they can just get paralleled. They're going to jump up to the upper portion of the box. So the first one was from the 7-way, and the red wire was from the aux input. And now we're going to parallel that wire from one Wago to the other junction, to supply power to the top of the box. Okay, now we're going to connect up the amp meter. I'm just going to mark this up here so you can see it a little better. There's an arrow on this. So I'm going to bring in my power. I'm going to bring in my power from this direction. So from the 7-way it'll go through here, and then from my auxiliary power it'll go that way. And you can see that represented here. On this particular model of box, we don't use an internal power supply, so this relay, this switch is not used. This charge port, that's a charge port, so if there was a battery in here, we had a way to charge that battery. So that's not there. But the input power we do want to run it through this way. So this would like represent the input power, that auxiliary power port. And then from the 7-way here, you can see it's going through that direction also. And then I'll just parallel onto a Wago there, and then it feeds up to the top part of the box. So next thing we're going to do is tie in the ground from the negative circuit from the 7-way to the Wago. This diagram is actually for a different box, but this is the basic part of that box that we're doing now. So this would actually go up to this one here. So you can see these two are just tied together. So in another version of the box, there's more circuits in it. So there's more junctions. But that's basically all we're doing. From the 7-way to the Wago, and then back up to the top part of the box. Now we're going to tie in the negative part of the circuit. So we're going to get our white wire from the 7-way down to the Wago that's in the bottom part of the box. And then we're going to tie that in to the Wago at the top part of the box. So that negative circuit's just one giant paralleled circuit. Now we're just going to check and see that the lid will go on. We still have more wires to shove in there once we wire up the 7-way. That's why there's kind of a blank spot on the right side of the face of that, right? You can see that's where the 7-way goes. So here's a diagram I made up of the 7-way. We're going to wire that up next. You can see the black is going to the 12-volt, which is the top part of the plug. And then the green is on the other top part of the plug. That's your marker lights. And the two side ones are going to be your turn signals. Brown's the right turn, red's the left turn. Then at the bottom portion, you have your brake and your negative. White wire is your negative. And then your center post is your auxiliary, or in our case, it's going to be for the backup light. The way I remember, or how I taught myself, I've been wiring these for a long time. When I started, every single truck had to be wired. Nothing was pre-wired. We had to put hitches on, the whole bit. The trucks didn't come with anything ready to tow a trailer with. So the way I taught myself to remember how a 7-way is wired is, if you're looking at the truck side, so the opposite side of this one, the one on the left-hand side is your left turn, and the one on the right-hand side was your right turn. So I had 2 of the 7 positions figured out that easy. Then I just remembered that the marker light was next to the left turn. Then after that, you know the top 2 are your 12-volt and your marker light. So, and then your ground or your negative was across from the 12-volt positive. So that's how I kind of memorized how the 7-way worked. So I leave that part of the 7-way in just to try to hold the wires in there in place as I feed them through there. Some of the wires I took out of an old box like I've mentioned in previous videos. Some wires are new, so we're going to put some ringlets on here. I don't always use ringlets when I wire up 7-ways. As a matter of fact, I kind of don't like to use them on a regular 7-way. If you're doing it on a vehicle or a trailer, I feel like it's a potential failure spot. So you're just adding another spot for that circuit to fail. In this case, I chop off the end of that 7-way socket, so I've got plenty of room to put them in. And now we're just going to wire it up. And I do wire it up with the ringlet offset pointing downward so the top is smooth. So it'll fit through the socket. And if the screw head is a dual, has a slot and a Phillips on it, I like to install them with a Phillips, and then I'll go back around with a standard screwdriver and cinch them up, make sure they're good and tight. And if you've wired up a 7-way before, this is all kind of self-explanatory. There's a notch or a keyed portion to line that up, put it in, then you've got a couple set screws to hold it in place. Then we're just going to reattach it to the box. I'm going to install the fuses. I use a 20 for the brake circuit and then a 5 for each of the light circuits. And I put them on the face here to make them easy to get to and to change them. If you want to lower them to make that circuit a little more sensitive, you can. I've never had to do that. Those sizes have been working fine. Now that it's put all together, we're going to test it, and I've made a little box here on the right that simulates a trailer. It's got some brake magnets in it, and you can see we've got power coming in through the 7-way, and you can see we're testing the brake circuit. So you can see there's 11 amps there, and I've got a pretty small battery on it, so it drug down the voltage a little bit. But this is in position 1, so we're going to go through with this bottom row, and that's going to check each circuit individually. So if there was a direct short in that circuit, it should blow one of the fuses. So now we're doing the left turn. Those are incandescent bulbs that I have in there. But I also have a LED bulb in the backup light, so you can see that it's not registering on the amp draw. So what I'm doing is I'm pulling that plug, and then there's a little switch on the back of the meter that you press for 4 seconds and it resets it. It zeroes the amp meter. So now when I turn it on, you can see there's an amp draw. Very small, but it's there. Now in position 0, that's where I can operate the dual flasher, and then you can see those switches there, turn them on and off. So if I just want one side on, I can do just one side. It's very rare I have to use those, but at the time I needed it for a brand that we were carrying. Then position 2, that turns on the marker lights, and then it runs the left turn at a slow speed and the right turn at a fast speed. So you can do a visual, walk around the trailer and do a visual on each of those circuits, and you can make sure that the left and right are wired correctly. While it's rare, I have had them come from the factory with the left and right hooked up backwards. Here I'm just plugging in that auxiliary power. So if the trailer didn't have power, you could put power into the box from there, and then you could check the lights that way. So we'll do another video on the parts that I used. Not that you have to use the parts I use whatever you want, but I'll go through what I have used on this. So don't forget to check the links to other videos. There's one that's going to show it actually hooked up to a trailer and to a vehicle and how it operates in real life. So we'll discuss some of the parts I've used to build these. This is the first container I was using, and I got these from Radio Shack, and I bought a lot of them. You know, Radio Shack's pretty much gone now, but this was just a great size box, and I really liked it. So when I had a hard time getting these, and I wanted to start putting batteries in them, I found this company here. I believe it's called Polycase, and you have to be careful when you order these if you use these. I like the smooth one. This one's textured, so I'd be careful. They sent me a bunch of textured when I'd ordered the smooth one, so I had to buy some of these. But this one was okay, and I found a company that would make me some lithium batteries, and they won't do custom ones anymore, but these worked pretty good. So I had a battery built in there, and this would fit in here along with the other stuff that we built in the video. And then of course they came out with, so you can see I've got the Velcro on there still. And these you can get them printed also. They sent me a sample. I can't find it, but they showed you a sample of like where you could get stuff printed on the face of this. So you can see here's the Radio Shack box. This is an older one that I had built, and before I was using the brake magnets, I had an incandescent bulb right here, and that would help me check the brake controllers. But if you had something different than a basic brake controller, it didn't work. That's why I started putting brake magnets in it. And then you have, like, this is one that's built with the poly case. You can see I've got a battery in this one. But those batteries are hard to get now. Then with some of the other boxes I built, they have the wireless feature, so I can control slide outs and stuff wirelessly. And so I put these all into one box. Here's the 7-way, here's the wireless. Got some aux inputs. This is to turn the battery on. So you can see there's an internal battery in here. So if I put it to position 2, you can see the lights flashing at a different speed. This plastic on this box is a little thicker, so it was a little harder to do the switches. And if this one opened up, you can see I've got a little 10 amp hour lithium battery inside there. That's why I went to this size box. I can also fit the wireless controller in here too. You can see there's the brake magnet, the 7-way. So with this size box here, I've got my 7-way tester plus my other tool that I like to use all in one container. So I see a lot of these videos when they make these, they use ammo cans, and I don't like the ammo can. Just the way it looks and everything. I wanted it to look more like this. So that's why I went out searching for containers. So I'm not going to put links. I'm just going to put up pictures here and descriptions of some of the ones I purchased. You can see here, this one already says currently not available, but that was a good size box to use. I just started searching for them on Amazon when I was building other projects and found something close to the size that would work. And then this is the part number for the polycase. So the polycase ones were fine. I'd probably recommend those if you can't find that size on Amazon, but you have to be careful with them in the heat. Then the vinyl lettering I just had done. Somebody helped me out with those on one of those Cricut machines, and that's how I got the lettering on there. It's much better and cleaner looking from what I was doing before. So the handles I use are just gate handles I got from Home Depot. So you see that one here, for this bigger box, I just bought a bigger one. So I like the handles on these. They've been working out real well. So some of the 7-ways I've been using, these are just really generic. I think they're just Chinese made, but when that one says Taiwan on it. But when I try to use the Bargeman or the Kurtz, the major brands, I couldn't get the trailers to plug into them. And so I noticed that these cheaper ones were a little more forgiving, and it didn't matter what the manufacturer was using. I was able to plug them in. So don't know what to really recommend on the 7-way. For now, I'm going with these cheaper ones. So when I went to look up what I had bought, of course it says currently unavailable. That's why I'm not putting links, just descriptions. I don't know why when I bought the name brands that I'm used to using, I'd go around the lot and I wasn't able to plug any of the trailers in. So I reordered some of these and installed those in the box, and then I didn't have any issues. So I don't know if it's going to be the luck of the draw. I don't know why they're not being consistent. So for the auxiliary power, I've used a few different things. Like a regular 12-volt plug. But if you had to put, a lot of power through this, these typically aren't rated very high. But you can see in some of my videos where I'm testing backup cameras, and so that's really convenient. But you can just make an adapter. So you can see now I'm using this XT90 here, used to use these banana plugs. They said these were rated at 20 amps, so I haven't had any issues with these. I just like this a little bit better right now because it's you can just plug it in one time instead of two separate inputs. You can do it that way. And I think there's XT60s, but they were rated a little lower, and then I found these, the XT90s. So you want to make sure you have these together before you solder stuff up. That way these don't get loose inside of there. And you can see this is just the banana plug I was using. So it's pretty basic. I still like these. And I haven't tested these out too much yet. But we'll get to that pretty soon. So these are XT90s. I don't remember why I went from the 60s to the 90s. Most people use the XT60, like you'll see those on solar applications. And it might just be these are panel mount. So I don't remember, but they work out. They do the job, so, and they're rated high enough. So I was using the banana plugs. It says they're for speakers or for meter leads, but I ran some amps through them, and they work great. Here's the cap. This is on the new one, so it's pretty hard to get out. But I'll show you on the meter. When we get to the meters where that reset button is. But that's the cap I use just to try to keep dust out of there. So the magnets, I was using some smaller ones, and they're hard to get now. And so I went with the bigger ones. I actually store this on the side of my toolbox. I just stick it to the side or face of one of my toolboxes. And like I said, I can attach it to the frame on the front of a fifth wheel. And so that's totally optional. It works great. You have to be careful when you set it down on the ground though, because then you'll pick up a lot of debris on these. So the bottom row switches here. I've done a lot of different things with that over the years. I'm just buying these here. You can get them in multicolored packs, but I do tend to use the 2 ambers. So I buy extra ambers. And then if the one with the built-in power pack is going to have a power switch, and I just kind of rotate what color I use with that. But if I was going to be more uniform, I'd probably use a red one. And then you can tell here the different colored post is your negative in, so that's so that light will operate. Then you have an in and an out. These have been working pretty good. I was trying to find like 20 amp rated switches so I could just run the power straight through like on the brake circuit. But I had some customers come in with shorted brake circuits and they would melt those wires, no matter what the rating was. So that's why you'll see a lot of this is just triggering relays sometimes. So this is a multicolored pack. I have been able to find individual colors all the same, like the ambers, for example. Like these here, these little push buttons here. I bought some that said they're rated at 20 amps, but you can see how small those are. And it did say 12 volt. So I quit using those. Then the double pull, double throw switch I use, you can make a reversing polarity switch out of these. I'm sure I've got a video on my page showing how that works. That's your position 1. So these are not momentary. These are on, off, on switches. So these are the ones I've used, several different brands, whatever I can find. And I haven't had any problems with these. No issues. They've been working well. So there's a lot of different switches, so you have to be careful when you're buying them. These here are, they tell you they're on, off, ons. So if you were going to make like a reversing polarity one, see it says momentary. So that's going to spring back when you let go of the switch. So there's a difference. Then for the left and right turn, this is the little switch I've been using for that. You can see those here. So with the power on, this is in the 0 position. I can turn on the flasher. And so if I just want left turn, I can turn the right one off. So like I've said, I haven't seen a lot of trailers that way, but we did have some. And these haven't been super reliable, these switches here. I've had some that went bad quickly or were bad out of the package. This is what I'm using for my indicator lights here. So you can check the truck side of the 7-way. Or in position 2, you can see them operate. These are hard to get, and it matters which color this is that goes into the lens. You'll see these are 12 volt AC/DC, but I've had a problem with these where they've sent me 24 volt and I clearly ordered 12. So you can see a different color here. Inside's actually green, so pretty self-explanatory, but you have to be careful with the blues. Right. Oh, it's in there. But because you can see that's clear also. These have been working pretty good, just as long as you get the right, they send you the right part. But I've liked these a lot. So for some reason I have a hard time searching for LED lights like this on Amazon. So if you put in that part number up there and then specify the color, that's how I've been finding these. The most frustrating thing for me has been these LEDs that I use for the fuse indicator lights. So when you have power going to the box, that's the main fuse. That's for the main power, but you can see this circuit here. Then you'll be able to tell that this circuit is blown. That's the main power to the whole box. That's why they all went out. But I like these. Look, they're all put together for you in the housing. They're 12 volt. They snap in, easy to wire. But once again, I got them from Radio Shack. So I have not been able to find these anywhere. So I was working on another project where I needed 12 volt LEDs. And so I found these. And I haven't used them a whole bunch, so I'm not sure how well they're going to work in the long term. And these are the holders I found. So you can panel mount them. Then the fuse holders. ATC panel mount fuse holders. I was happy when I found these. I've tried a lot of different ways of fusing and putting circuit breakers in. So circuit breakers are too slow reacting, so it really needs to be a fuse. So one of the videos I'll link is the evolution of this box, and you'll see all the different things I tried to use for circuit protection. And I was really happy when I found these panel mount ATC fuse holders. The meters I use are these here. You can see this one's a volt and an amp meter. There's a little button right there. That's what you would push and hold for 4 seconds to reset the amp meter. There's other settings on this one, so it can go back and forth between amps and volts. So you don't need 2 meters, but I want to see instantly the volt side. I don't want to have to wait however many seconds this thing takes to rotate through, so I use 2 meters so I can see the volts. I've had a lot of issues with these voltmeters. This brand seems to be working okay. The other brand I was using, they would burn out very quickly. You'd actually see a burn spot in the back here. So a lot of this stuff is really risky to try out, whether it's going to work or work out of the package or not. The amp meters with the shunt don't work well. I have to use one with a Hall effect sensor to be able to measure the amp draws that I want to measure. So that's the donut looking thing. That works great. Then the voltmeters, of course, the one that I've been using that's been working, currently unavailable. And the one that I had a lot of issues with was this one, and it also says currently unavailable. When I started building them, I used a shunt, one with a shunt. But this works much better for how I want the box to operate. So I can run the wires through here. So I had issues with wiring a shunt through there. So flashers, I don't use this style. This one says it's electronic. I didn't have any luck with these. I liked an electronic one. So you can see their plus and minus are labeled, and that's your out. And when I wanted to make one fast and one slow, I couldn't find anything like this. This is what I use now, and this actually turns, and you can change the speed. So that's worked out great. But before that, what I did is I took some of these, opened them up, and I changed out the capacitor in them. I haven't had to do that in a while, so I don't even remember what I used to do that. And then that would slow these down. So I put a white dot on here so I knew which one I modified. But now they have adjustable ones. So that makes it easier to install that feature. So the different relays I use, I like these because they're a little more compact. But I'll show you some of the problems I've been having with these. So you can read your coil there. But this one's got a direct short. Brand new out of the package. And I had quite a few of those like that, so I don't know if I would recommend this brand. I mean, when they've been in the boxes and they've been working great. Just a regular, if you got room, I just like a regular 30 amp. This one says 40 amp type relay, but if you look how these are set up, the outside ones are your coil and the outside ones are the coil. But this is your common, and that's your open, and that's your closed. So right now these two would be your closed. But on this one, if you think that this is the common, it is not. Even though it looked like, you see it's closed there, there's nothing here, but if I energize that, it doesn't change. This is the common on this side, away from the coil. See, that's open, and then that's your closed. So everybody's all wanting to know what the numbers are. I mean, get a meter, figure out your relay. It's that simple. I think I used this relay in a tutorial video on how relays work. But you can see this is the common that goes through to the switch there, and then it moves between these two posts. Then these little ones, you can see they're a 12 volt coil. I don't know if I've used a lot of these black ones yet. I know the one in the video was blue, but that was out of a different box. So besides this brand relay here, these haven't been an issue at all, no matter what brand I buy. So far, they've been okay. I'll link a video on how I made this board here. It's pretty simple. You can see the coil for the relay is on this end, and the coil on this one is on this end. So this wire parallels over to here. And then these are your contacts here. You can see it's just soldered to a little breadboard. So if you want to know how to make that, just check out the link for the other video. So I just bought various wire. We got some 10 gauge, and most what I use for the bigger circuits is 12 gauge. This wire is a little stiff. I wish I would have bought something different, but I've had this one quite a while. And there's some 14 gauges, depending on how much load you think is going to be going through the circuit, is the size wire you need to use. A lot of them I can get away with, smaller wire, 16 gauge. So this is an example of one of the brands of wires I've bought. There's charts all over the internet you can get to see what size fuse you use for what size wire and the length of the run. I use 12 gauge wire on the brake circuits. The switches that are just turning on relays or flashers, I mean, that can be a pretty small wire. down to 18 gauge is probably still a big size wire for a circuit like that. Some of the outputs, I might use a 14 or a 16. Most of the trailers now have LED lights on them, so there's not a lot of big draws. But just make sure if you do something like this that you're sizing fuses and wires correctly. Okay, well, hopefully I covered everything about the parts here in that video. I'm not going to say it's the end of the series because I may do some other ones in the future, different ways to power the box. And if you decide to take on a project like this, have fun with it. I have a lot of fun when I build them. And thanks for watching.